Hello everyone. This is the last day of this challenge, and if I come to the list what we were doing and what we have to do, so today we have to finish any ongoing project. So if you remember yesterday what we did work on SimCLR's self-supervised learning on CIFAR 10 data set, and this is a simple framework for contrastive learning of visual representation. We coded the first part of it. We what we have decided, have decided to split it into two parts. Yesterday we coded, we prepared the data for it. If I go and look at the code, we prepared the data for it, we added functions, and we for augmenting the images. We also looked at the images after the augmentation, some random four images, and then we prepared the encoder. We added our project head on it, and then we prepared the contrastive loss function for calculating the contrastive loss as well. Now what we have to do, we have to finish this ongoing project. So we'll use the same context window, and I'll say, hey, it is day uh, hey, it is day 30, and today we will finish the part 2 of the this SimCLR self-learning problem that we started yesterday. Okay, so let's wait for it to generate the response. Um, I am really sorry, I did not commit the code yesterday, so I'm going to commit the code first. So I'll say, hey, add day 29 30 commit. It was code for day 29, um, uh, part 1 of SimCLR, self-supervised learning, LEAR, and push it, and then it has generated the response. So what are we planning on doing today? So what are we doing? We have a lot to do today. So what are we doing, planning on doing today? uh, so today we'll do what? We will to look at the recap, but I have already explained you and we have already understood the recap. And then for today we are going to create pairs of augmented images, generate different views and a pairs of same images. Okay, then we will train the model on with the contrastive loss, the function that we had created yesterday. We'll use that for while training the model, and then we will evaluate the learned representations. We will evaluate the learned representation, that is, after training we will see how well all representations generalize. Okay. One. So in step 1 we have to prepare a data set for training, and the data set for training will now set up the data set to create pairs of augmented images. Okay, how are we doing that? Assume we already have the data set x at data set from the day 29. Yes, if we look at the code here, uh, we already have the data set stored in the X data set, right? Mhm. Yes. So we set couple of constants here: auto tune, batch size, and buffer size. Then we prepare the data set using this function called prepare underscore data set and pass this data set here. We convert it into tensor slices. Then we shuffle it, and then we batch it. We have used these techniques before also in a couple of our previous problems. So shuffling and batching are used to get the randomly sampled pairs of training, and prefetching is used to make sure that we have um, some data prepared while the current batch is in the process. And if I read it from here, it is used to improve the input pipeline performance by overlapping pre-processing and model execution. Okay, this is a complex thing, but we have used it before also. And the meaning is, what I've understood is that we prefetch it, that is we make sure that we have some data prefetched, already processed before we start the next execution, the next batch. So let's start with this function. uh, so we mentioned auto tune tf dot data dot auto tune, then we batch size is going to be 128, then buffer size is going to be a 10,000, 8, 2, 3, 4, and then prepare the method prepare data, take the x data here, and here we use what, x data becomes, sorry, here we are doing dataset creation. So dataset becomes TensorFlow dataset dot from TensorFlow slices and pass this data. Then the data set becomes, we are doing shuffling on this buffer size, and let's do that. Sorry, not on date. Shuffle on buffer size and map augmented data date and map it. Okay, so what are we doing? We are on each, after augmenting the data set from this data, we shuffle it, and number of parallel calls will be defined by the auto tune. And then the data set becomes dataset dot what are we doing next, batch, and we batch using the batch size, and then we prefetch using the auto tune. Perfect. And then we return data set, and then let's prepare the data set. Prepare x data. So we have the data set prepared. Now we'll go inside the training loop. So the loop involves generating two augmented views of each image and passing both views through the encoder and projection head that we have prepared yesterday, and calculating the contrastive loss. Okay, so we are going to use what all we have coded yesterday. So if I go, we are going to create the encoder, create the projection head. We already have created the projection head, I guess. We already have created the projection head. We already have created the encoder, right? So let's go and not do that again. uh, we do have to create an optimizer. I'll go ahead with creating, passing it. I'll see if I need to create it again and again. If not, I'll create it on the fly. So we mentioned the this is a TensorFlow function called train step. Here the augmented one and augmented two are the two images or two views of one image. Each image is augmented twice. Okay, so we will pass the function, the batch, to the data augment function that we have created yesterday to augment the image, and then we'll iterate. Gradient tape is used to compute the gradients of back propagation. Okay. So we are using gradient tape, and we get the two vectors that from the projection head. And projection head, if you remember, is already using the base layer, the base model. Here, see, we are mentioning the encoder already. So the project head, we will pass the augmented images. We'll mention that the training is true, create two vectors, and then we'll calculate the contrastive loss. Once done, we'll do what? Apply the gradients. We'll apply the gradient using the loss that we have calculated and the projection. Yeah. And then we'll apply the optimizer. Okay, that's how you're creating. Uh, Optimizer updates the parameter to minimize. Okay, so it updates the parameter to minimize the contrastive loss and then return the loss. Let's define it. So the training steps are going to be training steps are going to be tf dot function. This is a tf function. Tf train steps. Here we match the batch. We generate two augmented views of the image. So augmented, not here, typo, augmented one. Here we pass TensorFlow tf.map, not map function. The which function? Data augmented, and this batch, and then augmented to map function, data augmented, and batch. Then we will do what? Use gradient to compute. I'm sorry, my cat. Gradient tape for back propagation. So we'll do with tf gradient tape as tape. We'll do what? Uh, we'll encode and project both. So we'll do what? We'll have the first vector. We'll project data, not projection, project head, augmented one, trainable true. That's it. And zij project head, augmented to trainable true. Project head only, right? Correct. Then we have both the vectors. Calculate the loss, contrastive loss. So we'll do what? Loss will be calculated using the contrastive loss function past both the vectors that we have created from both the augmented images. And now apply the gradient. So we'll do what? So gradients is going to be tape gradient loss project head trainable on trainable variables, and then we'll do what? Optimizer. Let's call the optimizer. Let's define it here from TensorFlow dot keras dot optimizer import Adam, and we define the add optimizer with learning rate 0.003. Correct. So the optimizer will define here. Optimizer is going to be Adam learning rate 0.0003, and so optimizer dot apply gradient. Here we apply the zip version gradients that we have calculated, and yes, project had not dot trainable variables, and we will return the loss we have calculated. That's it. Now we'll evaluate. We will do train the model. We have prepared this function to prepared the training steps function. Now we will train the model. So we'll do what? Train the model. So we are going ahead with 10 epochs, and within each epoch we are calculating the mean. We pass it to the train step function for each batch, and then we sorry my cats, and then we get the so this epoch loss average keeps the track of the average loss per epoch. It keeps the track of the average loss per epoch, this one, and we update the loss that we have calculated, and then we print it. So let's start. Epochs we want 10, then for epoch in epochs, sorry, range epochs, and then the epoch loss average is going to be TensorFlow loss keras dot, just a second. Yes, TensorFlow keras and metric mean metrics and mean. Let's yeah, mean. This is the mean average loss of across of all the epochs. Then we'll do what? For batch in epoch, we will for batch in dataset, we'll do what? Loss will calculate using the train steps, and pass the dataset here, the batch here from the dataset, and update it in the average loss tracker. Updates the loss. And print, what are we printing? Epoch. We are printing the loss for epoch plus 1, because it starts with 0. Loss is epoch loss average, result summary. Not sorry, summary result in numpy. And just a second. So yes, this is done. Now let's do what? go and write the steps for evaluating the model. These are going to be normal steps we will use the classifier. Yeah, we'll compile the model and then train the model to uh, freeze the encoder and train a classifier. So we'll freeze the encoder first, evaluate the model. So we'll do what? Just a second. Okay, so we'll freeze the encoder. Encoder dot freeze trainable false. Uh, we'll create a classifier. We'll create a sequential classifier. Okay, we pass the encoder and then we have the output layer of 10 neurons with softmax activation, because it will print the probability of each class this image belongs to. So create a so we'll do create a, what are we creating? Simple classifier. So let's create it. C fire is going to be TensorFlow keras sequential. Here we pass sequentially first the encoder that we have created, and then we'll add the last layers. First import some layers, I'll mention it here. From TensorFlow keras layers, import dense layer, and we've already imported that layer. So let's do what? Add a dense layer of 10 neurons with activation function soft max. Done. Then we compile the model. Classifier.compile. Mention the optimizer as Adam, and loss sparse categorical intro and cross entropy, because this is a categorical problem and it is in digit form, so it is sparse categorical cross entropies. So loss and matrix is going to be accuracy, and we've already loaded the data, right? Why do we need to load the data? Okay, I'm just going to ask, we have already loaded the data in on day 9 and saved in X data. Why then why me? Okay, so I'll ask, then why are we loading it again? So it says we have already loaded the data and stored in X data during day 29. So there is no need to load it again. We can simply use the already loaded data X data and split it into training and testing purpose. We have combined it and then we split it. So okay, so we need to now use it. We can use train test split, or here only I can use it. No, acha, I needed it to create the images. I applied a lot of things on the X data, no? So I'll do what? From X. Here we are using it only, right? Okay. Yeah, let's import from TensorFlow, no, sklearn, model selection, import train test split, and then we'll do what? Split the data. We will split into training and validation data set. Training will be 80%, validation data set will be 20%. This will have data after all the modifications that we did. So x train, x uh, x train, x validation, train test split. We want x train, x validation. Okay, we will create the labels also. I'm a little confused. Let me wait. We concatenated it, then we normalized it. I will again split it. Says we'll create labels y train, y test, x train labels, y train labels. Okay, so let's save it. X y train, it is going to be y validation. Okay, and here we'll use it train text split on the x data. Test size is going to be 0.2, randomness 42, so that it generates the same output all the time. And we already have the labels, so I'm going to use them. And then let's fit it. Train the classifier. So we'll do what? Train the classifier fire. So we'll do what? Classifier dot fit x train and y train. Validation data is going to be x validation, y validation. How many epochs? Epochs 5, and batch size 128. I am a little confused. So we are checking, the goal is to evaluate how well the representation is learned in the self-supervised manner, transfer to a supervised task like classification. Okay. That is why we are creating it again. Though we have already, trained it using the custom training loop, we now want to evaluate how well, if we are transferring this learning to a supervised classification, how well it does. So that is what we are doing. So I'll do what? Run this. So this is the image that it has generated, and four images it generated. Now I have an error at the line number 57, 57, 57, 57, 57. It says 57 goes to the 52. So if we go to the line day 29 code here, which is create encoder. Here training we mentioned the trainings to be true. Okay, so the images are generated of a dog, bird, and we have the error again at line number 135, 135, 135, 135. Which will go to the okay 114. Encoder. So now I have the error here. Maybe I'm mistaking with the proper uh, what indentation. So I'll ask. Hmm. Okay, so it says it should be instantiated. Okay, we are not instantiating it. It was a function. I mean, I had to instantiate it. And then what? Again, we have problem. It is going to be training true, training tr true. Yes, it should work now. And the images it has generated are these, some random images. And we have the error at line number 77. So start with line number 135. Okay, okay, I have one. It should it should be running nicely now. Let's wait. Now we have the error at line number 136 when we are updating the average loss. So if I go here, we got the train steps from the batch. Then we update state, sorry, update the state and run it again. Is it last day? That's why I'm making so many mistakes. I don't know. Could be. It is taking some time to run. If it will take like more than 5 minutes, I'll stop it and run it in the evening because I have to go for the Google Dev Fest Pune. Uh, yes. So it says it runs slow on M1, M2 Max. It is asking me to run the legacy Keras optimizer instead. Uh, okay. Hmm. I guess it is preparing the data set. That is why it is taking some time because we have seen the model summary of the project head also. So yeah, it is taking some time in preparing the data set here. Then training will start. Let me do what? Let me pause it. Run it in the evening. Why should I make the video long on that? Added the code to the repository at page 29. Sorry. Train and evaluate sim CLR CLR model, and this is day 30 day 30 and commit it. Let's say what do we have in the status? Status get status nothing. Push it to the main branch. See it if we have the code. Yes, we have the code. Good. And let's run it in the algo, and I'll come and run this code or file in the evening and see what it produces. Thank you very much. So I ran the script, and model took too long to even do the augmentation on the images. It did not even show the timings, like this print output that we were printing, like while it gets trained for every epoch. So it was taking too long, so I had to stop it because I cannot give it like 2 to 5 hours. uh, and the main intent of this challenge is to learn how to do things, and we have learned how to work on SimCLR, self-supervised learning. So yes, it was a great day, and it was a great challenge to learn about the fundamentals of deep learning, convolutional neural networks, BERT, transformers, and advanced topics. So yes, thank you very much. Now the next challenge is not going to be any challenge. As in, I will not be working on any day long challenges. Instead, I am planning on doing week long or a month, 2 week long challenges. Sorry, problems. I don't know what problems are going to be for now, but yes, so I will no longer be making daily or posting daily videos. Instead, I'll focus on coding and building something constructive, something really good that I can, like that I can put it on my GitHub repository. And once done, I'll prepare the uh, uh, tech article like I used to do for my previous problems. So yes, this is what I'm targeting. I don't know what the problems are going to be, but yes, thank you very much those who have followed me in this challenge of doing 30 machine learning, of doing 30 deep learning projects in 30 days. Thank you very much.